Right, excellent. Let's get into it. So today I'll start with CAP-81, and then Jay is going to hop up here for some privacy stuff after that. Cool. So I just put a link to the CAP in the chat. But basically what this is it's a bit of a mix of a safety feature or a code hardening feature, as well as an optimization with respect to the eviction scan. So the eviction scan is this process where currently how it works is every ledger, we have this background thread that will scan some region of the bucket list. And then if it finds anything that's expired, it will essentially mark that this entry is evictable. And then at ledger close, we will decide whether or not to actually evict that entry. Now, this process has a couple of issues. First, it's very complex, and this is where the bug in Protocol 23 actually was in the eviction scan process. Additionally, it is expensive from a resources standpoint for a couple of reasons. You have to have this background thread that's running in parallel to your ledger apply, and you have to do a bunch of disk lookups. Now, one of the optimizations that was made in Protocol 23 is that all non-evicted Soroban state is now stored in memory. And so what this CAP proposes is to basically leverage this in-memory state. And instead of scanning the bucket list and doing all these disk lookups to look for a state that might be evictable, just looking directly in the in-memory state instead. And so I think this is fairly straightforward. But basically what we're going to do is instead of evicting entries sort of based on their bucket list ordering, which is sort of implementation specific to our database and very complex, we have a much simpler ordering. We're essentially just going to order everything first by its live until ledger sequence, and then by ledger key as a tiebreaker. And we're going to have a separate lane for persistent entries and temporary entries. At the end of every ledger, we'll then just look at this list and evict everything that is evictable in order up until we either hit the max entries to evict or the maximum bytes that we can evict, whichever limit occurs first. This should make the code base a lot simpler because we don't have to do this background eviction scan thing. Everything is just blocking in one thread. Everything is in the memory state, so we're also getting rid of a bunch of disk reads. A couple of small details here. One sort of observable change is that today we have one sort of maximum entries to evict that applies both to temporary and persistent. This breaks that into two separate sort of limits. We've observed that the temporary entries grow a lot faster than persistent entries. So this allows us to essentially crank up the amount of temporary entries we evict more than the persistent entries. The other thing too is that there's a maximum bytes to evict that applies to persistent and not to temporary. This is because temporary entries eviction is quite fast and simple. You just do a delete. However, for persistent entries, you actually have to do a write in writing them to the hot archive, which is why we need that limit to avoid writing too many bytes on ledger close. So it's kind of an overview. Any questions, concerns, anything folks want to talk about? I see a couple people typing, so I'll let them finish their thoughts. Seems pretty straightforward. Memory versus disk. Any trade-offs identified? One trade-off is that this ordering is a little bit more expensive to maintain. Currently, we don't have to maintain any ordering for eviction, but this does necessitate keeping a list of live ledger keys organized by or sorted by entry or expiration ledger and key. Now, the advantage to this is that you don't actually need to keep the entire list in memory. So basically, you can identify, say, what entries will be evictable in the next 5 ledgers, and you can just sort those entries. So you don't actually, even if the entire state is a couple gigabytes large and has millions of entries, you don't have to maintain the sorted order of all million entries. you can just sort of take a subset of those entries sorted. The reason we didn't do this before is because entries lived on disk, and so sort of keeping this partially sorted list was actually very expensive because you do a bunch of disk reads in order to maintain your list. Because of in-memory state, that concern is no longer there, which is why this makes sense. And so the protocol will define the ordering for all entries, but the implementation will only have to keep a small subset of them sorted at any given time. Um, Rowbear, are there any edge cases where an entry could expire in X, but there are too many entries to evict, and so the entry remains live past to TL? Yes, that actually is what happens today. So today, entries are not evicted immediately on their archival ledger. Now, that doesn't mean the entry stays live. So the semantics of live versus archive will remain the same as they are today. So today, say an entry is archived on ledger 10, but doesn't get evicted until ledger 15. If you try to access that on ledger 12, even though the entry hasn't been evicted yet, it's still considered archived. And so your transaction is still going to fail and still going to get the archived error code. So under this proposal, it's the exact same. A entry might not be evicted immediately, but it's still considered archived. This actually helps a lot because with this change, we'll be able to evict entries much closer to their archival ledger, whereas today, entries can actually live for a long time in the archive state before they get evicted. Cool. Let's see. I see no more typing. I think those. Thank you for those questions. I will going once, going twice. Sold. Okay. Cool. I guess that concludes the CAP-81 chat today. Now I think Jay has some stuff to share. So if you want to hop on stage. Whoops. All right. Thank y'all.
Can you hear me? Okay. Yeah. Hi everyone. Yes, today I'm talking about CAP-82, which is a checked 256-bit integer arithmetic host functions. Yeah, I think this cap is fairly straightforward. We are adding 8 new host functions that are almost identical to the 8 existing host functions that performs integer arithmetics. Those are U256 and I256. The reason we are adding them is that the return, the compute of those host functions currently um, do not allow the contract calls to make fallable calls, meaning that if a arithmetic function overflows, it will just panic instead of making it um, actionable. So contract that will basically they can't act on potential values that overflow. This is important because for some libraries that ecosystem develop, such as um, the fixed point arithmetics functions, using the U256 as a building blocks require that you are able to check on overflow and be able to come back and do additional logic on top of. So the current design that doesn't allow overflow to occur really hinders such development. So yeah, so these new host functions supports that. So in terms of semantics, it's very similar. I'm just taking one example, U256 added checked add. So adding the two numbers, if it overflows, it will return a void variant of the val. So originally, the return value is a U256 val, which can only be representing a U256 type. Right now, in the new proposal, this is a val, more generic version val that could be both U256 or a void. Any other types, obviously, will still get rejected. Like you can't be expecting a vector return. on an add function. That's obvious. Yeah, so I think that's all that is to the semantics. So a couple of more details to mention. I think the first obvious question is that I'm seeing a question. Wait, that's okay. Yeah, exactly. You can map void into option type, or you can have your own custom logic to act on the void value instead of just panicking. Yeah. So the list here is 8 functions, and originally the list is 16. The unchecked version has 16, and this one only has 8 because some of the functions that are very trivial to add, the checked version, such as division, a U256 integer division, you just need to check the denominator to be non-zero. Similarly for I256 division, shift operations. So that saves us some additional footprint in the host to maintain and to implement. Yeah, so I think this is, yeah, nothing really is changing. There's no new added cost types. There's no new dependencies in terms of host. That's really the same functionality, but exposing it in a more friendly and generic way. Yeah, I guess the first I guess obvious question is why don't we just change the existing host functions, change its return type? Um, that's that is because we want to maintain the interface compatibility. Not just that new function. If we change it to val, it's a broader type. So any old contract that relies on U256 will technically still work, but there may be some flows cases such that a contract rely on the panicking behavior, which now will be kind of silently removed. So this could cause some like troubles for some contracts. So that's why I wanted to change the return type. We just have to add a new variant and then adapt that in the SDK. Uh, yeah, I think that's it. Any questions? Cool. Yeah, I think so too. All right. If there's no more question, I would hand it back to Carsten, or do you want me just? Oh, I'll pause for a second. I don't see Lee on this call. Oh, he is, but if you want to add any comments. Okay, we can do this offline as well. Whatever, up to you. All right. If no more questions, I guess Carsten is typing. All right. Thank you, everyone. I'll see you next time.